All right, so in this video, we're going to do questions 5 and 6. And it says Patricia creates a cubic polynomial p of x with leading coefficient 1. The zeros of the function are 2, 3, and negative 6. So leading coefficient is 1, and the zeros are 2, 3, and negative 6. You want to write an equation for p of x, then sketch the polynomial on the axis below. All right, so let's create the polynomial first. P of x equals to, well, the leading term is 1, so I'm going to put a 1 in front. And remember, the zeros are going to be the opposite signs of the factors. So if my first 0 is 2, let's put that in red, actually. If the first 0 is 2, the factor is going to be x minus 2. Remember, in the factor, the 0 is the opposite sign. Matter of fact, I want to zoom a little bit, and I want to erase this because I want to move this over to have some more space. So p of x, p of x equals, the leading coefficient is 1. So put that in front. Now we're going to multiply that, in this case, by x minus 2, which is from this 0 over here. Put that in red. The other 0 is going to be positive 3. So we're going to put that in blue. It's going to be times the factor of x minus 3. And now I'm going to put this one in green. And the last 0 is going to be negative 6. So that factor is going to be x plus 6. Once again, remember, the factor has the opposite sign from the 0. And these goes both ways. So I'm going to put an arrow here. Put another arrow on this side. Put one more on this side here. And then that's our polynomial. And we can rewrite it. The 1 doesn't do anything to it on the outside. So p of x equals to x minus 2 times x minus 3 times x plus 6. There we go. The polynomial is positive. So to sketch this polynomial, basically, we put our zeros on the x-axis. So that's going to be 2 here, 3 here, negative 6 on this side. And remember, the leading coefficient must be positive. So it looks something like this. A rough sketch. Okay, so I'm not an artist, so you're going to forgive me on this one. Something like that. And there you go. And then if you want to, you can also confirm this in your graphing calculator by putting the function in to the graphing calculator. So that's going to be x minus 2 times x minus 3 times x plus 6. And when you graph it, and I kind of want to make this a little bit different. So I'm going to hit window, and I want to change the scales. I'll make my y max, in this case, delete, make that 100. And in this case, make that minimum negative 100. Regraph. And if I zoom in, it kind of looks like that. Yep, that's good enough. That's good enough. I guess what I'll do is I'll go back to window. I'll make my x a little bit smaller in this case, so let's delete that. Let's make that 7 for the max, and delete that again. Make that -7 just for aesthetics in this case. Even still, when you zoom in, that's how it should look, right? It should go through both the 2 and the 3. All right, guys, so that is it for number 5. Actually, I don't know if I can move that over on this side. There's something new every day. Let's do number 6. It says, sketch a graph of a polynomial p of x given the criteria below. The zeros are only at -5, 1, and 4. And then we have some end behavior. As x goes towards as x goes towards positive infinity, p of x approaches -infinity. And as x approaches -infinity, the polynomial p of x also approaches -infinity. So what I want to do is I first want to label my axes. In this case, y is the same thing as saying p of x. And x is x. So on your exam, you can label it as well. On this side, x approaches infinity. On the right side. On the left side, x approaches -infinity. Now, if you look up, right, p of x approaches positive infinity because it's going up forever and ever and ever. And then down here, p of x approaches -infinity. So you should label it just for the aesthetics for doing this question. So let's put our zeros on our x-axis. That's -5. That's +1. And that is 4. So now let's graph the function based on this criteria. As x goes towards positive infinity, the function goes towards -infinity. So this means right side down. So the function is going to be down on the right side. And then this one over here means as x goes towards -infinity, the function is also going towards -infinity. So that means left side down. So right side is going down, left side is going down. Here is one example of a sketch that we can draw. So it's down on the right. So on the right side, I'm going to go down. And on the left side, the function also goes down. So here's one example. But not the only example. I'm going to draw my graph like this. And there you go. Now, why did I draw my graph like that? Well, the only zeros is -5, +1, and 4. So it must contact with x equals -5, x equals 1, and x equals 4. But the reason why I decided to loop it right over here is because in this case, right, if the right side is going down, if this was to go back up, it'll have to come down again, which means that there is another 0. But it said in the directions that the zeros are only at -5, +1, and +4. So the graph does not go straight through. I can curve it at x equals 4 and get my desired results. I could have also drawn the graph like this. There's no one way to draw this graph. I could have also sketched the graph. I'm going to use blue in this case. I could have curved it at -5, curved it, and go up through 1, and then go down through 4. That's another option as well. In this case, we curved it at x equals -5. So there should be at least one curve in this case, right? One curve point where it loops back around. And I can also sketch it like this as well. I'll put that in green. Here's another example where it can go through 5, curve at 1, curve back up, and go through 4. Where in this case, we curved it at 1. Excuse me. So I'm going to leave this one here as the answer, but there is more than one answer. You have 3 possibilities in this case. All right, that is it for this one. I'll catch you in the next one. Take care.